Okay, everybody, welcome to what's going to be a YouTube series about robot design. In this series, this is the first of the series. We're going to cover several things. We're going to cover frame building, wheels, axles, gears, sprockets and chains, pulleys and belts, using motors together in a pair. We're going to cover some 4-bar linkage designs. We're going to move from there into programming things like using limits, using timers, using the brain. We're going to cover touch LED. We're going to cover multi-speed drivetrains. We're going to cover using variables and more. And if you have topics that you want covered, feel free to post them in the comments, and we'll try to cover them for you. In the first one here, we're going to cover frame building, just some general principles of frame design, and we're going to start with the flex design, because you either built flex or saw flex, and you remember what flex did well, and you remember what flex didn't do well. And we're really going to touch on, as far as frame building goes, about one of the big problems that Flex had, which was at the back of the robot, if you remember at the very back, there was one of those black corner pieces that actually held the frame together on the back. And you can see where we're pointing with the pencil there. And you can also see where you're pointing with the upright pieces. That's all the load was connected to that back crossbar, and then the back crossbar is held to the side frames with one black piece, and that black piece had 2 pegs that held it together. And if you remember, that thing come apart a lot. Our team had problems with that for as long as we had the robot until it was redesigned. Okay. So if you look at the robot that the team redesigned this year, and we're going to hold it up so you can see it real well. We want you to get a good look at the corners there, about how it's held together now. We use black pieces, but they've got 5 pegs holding it together. And if you flip it upside down here so you can really see it, there's actually 2 of those black pieces with pegs in. One's got 5 pegs, and the other has 4 pegs. So there's actually 9 pegs holding that together right there. After that was done, the team never had a problem with frame coming apart back there in the corners. Okay, we'll set this robot back down, and we're going to compare the differences here. So if you look back at the Flex again, all the load was coming down on these back pieces here. And where it was joined with those blue pegs, some of you know if you pulled too hard, or it would actually pull apart right there. So let's take this yellow piece and talk about that now. When you're trying to build a good strong frame, you want to avoid a pulling design like this, okay? If you've got this type of design that your strength is relying on, it's going to come apart on you. You want to redesign, if at all possible, so a pulling design where you pull pegs apart actually pulls in. You see he's pulling on that real hard right now, and that's not coming apart. You can pull on it, you can even twist it some, and that's going to be much, much stronger. So let's take the robot that the team competed with this year, flip it upside down, and you see the uprights here, okay? Here's all the forces coming in down this upright piece, and now flip it upside down. And look how that upright piece is joined. It's joined directly to the frame where the wheels themselves are. So, and it's joined with 5 pegs. So not only do we not have the force on the crossbars. The force is on the side beams themselves, which is directly connected to the wheels themselves, which transmits the force very well straight down. And you've moved from a design where you have to pull pegs apart to a design where you're actually twisting pegs apart. So put the robot back down. If you look at the robot from the side, you see the purple brace that we've got connecting the upright to the yellow frame. The team put that brace on there mainly for looks. That brace was not actually even required. The robot was strong enough without the brace, due to the way the upright is joined to the frame. It was very strong design, never came loose the entire competition season. The back corners with those 9 pegs, very, very strong design, did not come loose the entire competition season. So pay attention to how you join things together. Try to use pegs in a way that they're pulled sideways and not tried to pull apart. Okay? All right, that wraps up this basic frame construction video. There'll be others. So we look forward to your questions. And that's it for right now.